All right. So there's two laws that we need to learn, and there's a really distinct reason as to why these laws exist. And I want to see if you could maybe figure out why. We've already learned a little bit of trigonometry, and when we learned it, we learned the whole SOHCAHTOA thing, right? It was like SOHCAHTOA. All right, so this was helpful because if I knew two sides of a triangle, I could find an angle. Or if I knew an angle and maybe one of the sides, I could find the other side. All right, so that's what's helpful about trigonometry. So then, why is this not all encompassing? Why would we need another kind of law? I want you to think about that.
Oh, if it's not a right triangle.
That's exactly right. Does every triangle have a hypotenuse? No, right? An equilateral, equiangular triangle doesn't have a hypotenuse. So I couldn't use any of this if I needed to find some missing parts of a non-right triangle. So that's the biggest restriction about SOHCAHTOA, is that it only works with right triangles. Okay, so therefore, what we have to do is we have to develop these other two laws that we can use with non-right triangles so that we can find missing sides and missing angles. So let's take this, for example. This is a triangle ABC, and it's not a right triangle. But what if we were to draw the altitude from angle B and call it H? So what's true about an altitude? Okay, good. It's going to be the height. It is perpendicular. So when it comes down here, it is going to create a right angle on either side. So notice I can take what was not a right triangle and break it up into two different right triangles. So why don't we start by looking at the small right triangle that's on the right-hand side. So let's just look at this one right here. And this we called H. If we wanted to, we could go ahead and use SOHCAHTOA. We could kind of do any of the SOHCAHTOA. Well, we can't really do SOHCAHTOA from B because it's not the whole angle B. And we can never do SOHCAHTOA from the right angle. So let's do it from here. So if we were standing right here, we could say that the sine of angle C is the opposite side, right? This is your opposite side, H, divided by the hypotenuse, which is A. So far, so good? Okay, so this is what I'm doing is I'm proving to you where the formula comes from. Hopefully what I've done so far makes sense. Now, if I decide to do the exact same thing, but now I do it from the perspective of this right triangle on the left, so the small right triangle on the left-hand side, and now I maybe stand at angle A, I could set up this equation right here. Sine of angle A is the opposite over the hypotenuse. So far, so good? Okay, so when we derive formulas, we make true statements, and then we try to look at where we can relate them to each other. So do these two equations have something in common? Don't they both have H in them? So if I actually solved each of these things for H, so like for this one, if I put this over 1 and I cross multiplied, I would get that H equals A multiplied by sine of C. And this one, if I did the same thing, if I slapped that over 1 and I cross multiplied, I'd get H is equal to C times sine of A. What we could then do is say that these two things are equal to each other. So let's do that on the next slide. So A times sine of C, that's what came from the what I had in green, and then what I had in blue, right? Because we set each of these equal to h, so they're equal to each other. All right, so essentially that's my law of sines. But what we like to do is maybe like rearrange it in a way that's easy to remember. So I don't expect you to, I'm not asking you to derive, but if you decide to become a mathematician and make up your own formula, you might wish to consider doing something like dividing it by AC. Because when you do that, notice this and this divide away, this and this divide away, and what you are left with is sine of angle A divided by side A equals sine of angle C divided by side C. So they kind of line up and they go together. That is the law of sines. So what we have is a ratio. The sine value of any angle can be divided by the side that's across from it, and that ratio will be exactly the same for all three combinations of angles and sides across. So I'm going to spare you the derivation of the third piece. This is basically your law of sines. So if we did it one more time, we would get this, the same sort of thing with sine C over side length C. Now, have you ever seen an equation with two equal signs? It's like, how do you solve that? That's a little bit weird. So what we do is, we have this relationship where all three of these ratios are equal, but you're only ever going to use two of them at a time. So we only use two of the three at a time. Depending on what you have in the problem. If you have information about angle A, then you're probably going to use this ratio. If you have information about side length B, then you're going to use this one and this one, so it could be any two of those three. All right, so let's try it out. So sometimes the triangles are already named for you. If they're not named for you, you can just randomly name them A, B, C. It should not matter. All right, we need to find angle B. So let's start with what we know, what is given. We know angle A is 55, so therefore this is side A. Right? It's across from it. So we can set this up. Sine of 55 divided by 5 is one ratio. And that should be equal to, if this is what we wish to find, we'll just call this B for angle B. It is then across from little b. So then I would have sine of angle B across over 6. So there's our equation. Let's go ahead and solve it. So I would start by cross multiplying. And I'm going to wait to grab my calculator and try to do this all in one step. I'll show you what I mean. If I do this diagonal, I would have 5 multiplied by sine of b. That will equal 6 multiplied by sine of 55. And then I need sine of b by itself. So let's go ahead and just divide by the 5. So then sine of b will equal what I get from this. And you're going to get the closest answer if you try to do all of this in your calculator in one step. So try in the calculator in one step. Because remember, you could get like rounding error. So 6 times 55. Make sure to end the parentheses on the 55. And I get 0.98298.
Yeah.
Okay, so And I mean, I could keep going. All right, now, that is not my final answer. Right? Because B is an angle. So I still need this. How do I find an angle if it's set up in a sine equation like this? You're close. It's that inverse one. It's the inverse sine. So in order to find B, we need to do inverse sine. And I'll give you a hint, you're going to get your closest answer if you do this. Most calculators have that. So try that. Otherwise, you can type this in. Yours just might be round, you might get a little rounding error. So if I do second inverse sine and I do the answer, on these calculators, it's on the little negative button. If you do second answer, ANS, I get 79.41. So angle B is 79.41. Okay. Now suppose you rounded this, and let's say you did this, inverse sine of 0.98, and you just rounded it to that. I want you to see how different it would be. $78.5.
Wow.
Right? That's kind of quite a bit different. It's like 1 whole degree different. And you really didn't round it by that much. So that can happen. It's not a huge deal, but being aware of it is half the battle. Yeah.
Could you scroll up a little bit? So why wasn't the one on the left divided by 6 as well? The sign of the one down. Yeah, there.
So this is what I want to isolate. And so the B is stuck inside the sign, but the 5's not. So I can divide the 5 to the other side. All right, so 70, what did I get? 79.4. So if this is 79.4 degrees, if I asked you to tell me what angle C was, could you answer it?
Yes. Yeah.
Would you need the law of sines?
No.
No, right? Because if you know that this is 55 and this is 79.4, you could just subtract them both from 180 and figure that one out. If I asked you for side length C, would you need law of sines?
Yes.
You would need to use the ratio, but you would have to figure out this angle first, right? If you want to find this side length, you would have to know its angle. You have to know one of those two things to find the other one. So sometimes the questions may come with multiple parts, like it'll say find angle B, find angle C, find side C. Okay, so if you have 2 of the angles, the third one's easy to find, but if you need the side, you would have to set up another pair of ratios. All right. So that's basically it. It's fairly, that's the hardest version of the way that the law of sines could come at you. This one's even easier, I think. It's the same setup with the ratios, but this one's easier because you don't have to do that extra step of the inverse sine. So for here, if I know that this is 50, this is little a. So I could have sine of 50 divided by 20 equals, let's see here, this goes with that. So sine of 73 over little b. Go ahead and do your cross multiplying. Now let's try to wait to put this in your calculator until you can do it in one step. It'll just help you with the whole rounding error thing. All right, so b gets multiplied by sine 50. When you do that diagonal, it equals 20 times sine 73. And then to get b by itself, we would divide by sine of 50. And so hopefully it's easy enough to put this in your calculator in one step, because those are going to cancel out. So try that out. We can compare what we get. 20.73 divided by sine of 50. Yeah, 24.96, 24.97, depending on how you round it. There you go. Okay. So that is what we would use anytime it's not a right triangle and we have angles, but we need to find sides, or we have sides and we need to find angles. So your homework tonight would be the law of sines worksheet. I will answer questions about that tomorrow. I'm not going to take it from you tomorrow, but I will answer questions from that. Since we have a little time, what I would like to do is do a little chapter 9 review. But why don't you tuck all your stuff away, and then I'm going to break us up into groups.